Okay, next we go on with example 2 in the sketching of absolute value function. Now let's say I have the function fx equals to 3 minus modulus 2x plus 1. So once again, we begin with the type of function. So the type we would like to have the absolute value function. Sorry, here's supposed to be absolute value function in the form of fx equals to a modulus x mx plus c plus k. And if you're corresponding to the example we have here, the a will refer to the coefficient, the numbers that multiply with modulus, which is -1. The m is the coefficient of x, which is 2. The c, the k. So it happens to fulfill the form that we require. Then next, step 2, the shape of the graph. So the shape of the graph, how we're going to decide is that we're going to decide based on the sign on the modulus. So we notice that this is the case that we have negative modulus. So how we decide the shape is that we begin with the idea of having the V shape for positive modulus. So if let's say I would like to change the sign to negative modulus, I would like to change the sign on the function absolute. Therefore, I will need to consider flip the graph. I need to consider flip the graph vertically and get the answer as an inverted V shape. And therefore, with that, we go on with determine the special point in the step 3. The special point here is referred to the curves. The curves will refer to this sharp point here. So what is the coordinate of this sharp point here? So guys and girls, again, this happens to be the shape that I obtained from step 2. So from here, I happens to find out that the coordinates that I have for these curves here, the x coordinate is based on the 2x plus 1 inside the modulus. I make it equal 0. I get x equals to -1/2. Then the y coordinate will be just refer to the 3 here, y equals to 3. So as a result, the curves I have here is -1/2, 3. And when the time reach until here, by right, if let's say you want to decide what is the domain and range, I can, based on these curves here and the shape of the graph I have, I find out that the domain, I notice that I can have all the way travel from infinity to infinity for the domain. The range, so domain is see that how far the graph can extend left to right. Range, we would like to see how far it can extend up and down in this case here. So therefore, the range I can reach as high as the point y equals 3, as low as y is infinity, -infinity. So therefore, this is the answer of my range if you like to determine the domain and range. Then the next, step 4, we would like to go on with the intercept on the x and y axis. If let's say they exist, so whether exists or not, we're going to decide from a rough sketch. So the rough sketch using the coordinate -1/2 and 3, I find out that this is happen to be the rough sketch I have. Again, the rough sketch may not represent the actual location of your y and x intercept. It just gives us the idea that we see, is it possible to have y intercept and x intercept? And from the rough sketch here, we see that both of the x and y intercept happen to be exist. But what is the actual coordinate? We need to go on with calculations. So we notice that x and y intercept happen to exist. So we need calculation to verify their location. So y-intercept, we have x equal to 0. So it gives me fx equals to 2. As a result, y-intercept is 2. Follow x-intercept, it will obtain from, I'm letting fx equal to 0. When the time I try to solve it, I find out that I have x equals to -2 and 1. So these are the two corresponding value I have for x-intercept. And from all this information from step 1 until step 4, I can come to conclusion of my graph. It will happen to be in this form here. It cut the y-intercept, it cut the y-axis at 2, cut the x-axis at -2 and 1. And therefore, I have done my graph. And reminder again, in your graph, you must make sure you label the x and y-axis you label the origin, you label the graph. So in this case here, the graph is function f. You label the y and x intercept. So y and x intercept you label, and also your special point, the curves in this case here. So therefore, we have done for example number 2 in graph sketching for the case of absolute value functions.